Hey guys, so here's part 3 of the 10.1 Day 1 notes. We're now going to combine the ideas of factorial and then the fundamental counting principle to find the different number of ways to do stuff here. Okay, so number 5, it says, as I went to pay for the coffee, I saw a sign saying, win free coffee for you. Choose 4 different digits from 1 to 9 to create a 4-digit passcode. Enter your passcode online, and if you match our secret passcode, you'll win. How many different passcodes could I choose? Okay, so notice I have to have 4 digits. So I have 1, 2, 3, 4. Now from here, what I'm wanting to think about is that I can choose any numbers from 1 to 9, okay? And so if we think about here, if we have our first digit, right, we need to think about, well, how many numbers can I choose from, basically? Well, 1 to 9, there's 9 digits total, so I have 9 options, okay? But now, when I go to my next one, I don't have that first digit anymore. So let's say I choose 2 as my first digit. Well, I can't choose 2 again in my next one. So then how many digits am I left with next? That's going to be 8. Now for the next one. So let's say I did 2, 3. That was my digits there. I can't choose 2 or 3 in my third digit. So now, how many am I left with? That'll be 7. And then, of course, the last one will be 6. So it's talking about how many options you have left for each of those different digits. So now I go ahead and I multiply all those out. And I have 3,024 ways of having different passcodes, okay? Okay, let's go ahead and do number 6. Once again, it's Dunkin' Donuts. Okay, it's thinking about offering a promotion to win free coffee for life. Wouldn't that be great? Okay, for this contest, the customer will have to use all the digits from 1 to 9 to create a 9-digit passcode. Each digit can only be used once. How many ways can this be done? Okay, so this is actually going to be similar to what we just did in the last one. Now, instead of having now 4 digits, I have to choose 9. So I'm going to do like 9 dash marks to indicate those 9 digits. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Now notice it said that each digit can only be used once. So if I have my first digit and I pick 2 as the number, then I can't use 2 anymore throughout my 9-digit code, okay? So let's think about options. So we know if we go from 1 to 9, we have 9 total numbers or total options. My first one, which I pick, I have 9 options to choose from, okay? But once I use that digit and I go to my second digit, I can't use that first digit anymore. So how many options am I left with? That should be 8. Well, now what about the next one? 7. Okay, what about the next one there? 6. Then 5. And we have 4 options here. 3 and 2 and 1. Okay. So now we multiply this out. And this may look familiar, remember? When we take a number and then multiply it by the numbers below it, doesn't this also look like this could have been a factorial? Yeah, so we could also use 9 factorial to represent this as our final answer. So our final answer here, if we plug this into, so now you can just do it into your calculator. What I would do is put 9 factorial. So don't forget, you can put 9, then you go to math, go over to prob, click number 4, and that's how you're going to get your factorial. So here we have about 362,880 ways. Okay, let's go ahead and do the next one. Okay, number 7, a multiple choice test has 10 questions with 4 answer choices for the first 5 and 3 answer choices for the second 5. How many different ways can you complete the test? Okay, so the total number of questions we have is 10. So I have basically 10 things I have to complete. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now, it said for the first 5 questions, there's 4. So I have 1, 2, 3, 4, 5. So these are my first 5 questions. Okay. And I have 4 answer choices. Now, no, when we are doing a test, right, you usually have, let's say, A, B, C, D. You can choose A for all of those, right? Or you could do A, B, B. So that means that you can repeat the choices if you want to. So if we think about the first question, how many options can I choose from? 4. But what about the second question I answer? I also have 4 because I can still choose A, B, C, or D, or whatever letters they use. What about the third one? Same thing, 4. Fourth one, 4, and fifth one as well. Now, it says we only have 3 answer choices for the second 5 problems. Okay, so here, this means like we would only have A, B, C. So on my 5th problem, I can choose either A, B, or C. So I have 3 options. But what about when I do my 6th problem? I still have those 3 options. I can choose A, B, C. And then for my 7th, same thing, 8th, 9th, and 10th. Okay? So now here, what I'm going to do is just take all of these values and multiply it. Now you could rewrite this in a certain way if you don't like just plugging all of this into your calculator. Notice that we have the same numbers, so we have 4, and let's count how many 4s we have. 1, 2, 3, 4, 5. So that's saying like 4 to the 5th power, meaning that you have 5 of the 4s that you're multiplying. And then we can also multiply that with our 3s. How many 3s do we see here that we're multiplying? 5. So this could be another way that you could plug into your calculator to get your final answer. So when you just plug this in, we do get a 248,832 as our final answer. Okay, let's go ahead and do our next problem. Okay, so now in the state of Missouri, a license plate is 3 letters followed by 3 digits, which that is true there. So how many different license plates are possible if digits and letters can be repeated? So this is kind of similar to what we have done so far in the past few problems. Okay, we have 3 letters. I'm going to do this here. We have 3 letters, so I have 1, 2, 3, and then 3 digits, 1, 2, 3. Now we have to think, okay, letters. How many letters are there in the alphabet? There's 26, so hopefully you knew that. Now the letters can be repeated, so we think about our first letter, how many options can we choose from? Well, all 26. Now what about the next one though? If the letters can be repeated, remember we can have A and then another A. So meaning that we still have 26 options. What about our third letter? We once again have 26 options. Now let's think about our digits. Now we've been working with digits that are between 1 and 9. But also in a license plate, you can use 0 as a digit as well. So we think about that, there are actually 10 total digits. We go 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. So that means we have 10 total. So kind of be careful on that. So once again, the digits can also be repeated. So that means I can do 0, 0, 0. So for my first option for the digit, I have 10 options. For my next one, because I can repeat it, I still have all 10. And same thing for my third. So now here, I can go ahead and multiply. Just put this into your calculator. And remember, a way of doing this, you can also think of, since we have the same base here, so 26 for the same number here, and I'm doing it 3 times, I can represent it 26 to the third, and multiplying by 10, because I have the same number, and that's also to the third. So that's just another way of writing it, and you can plug that into your calculator as well if you want to. Okay, so once we have done that, we calculate. So we get a very large number. It's like 17,576,000. I'll be right back. Okay, let's go ahead and do the next one. So we are still using the same amount. So we still have 3 letters followed by 3 digits. But notice this time, our digits and letters can't be repeated. So when we think about our first letter, well, we still have all 26 options. Now let's say we use A for our first letter. Now since things can't be repeated, I can't use it again. So how many options of letters am I left with now? That's going to be 25. So let's say I used A and B. So now for my third letter, I can't use those 2. So how many options am I left with letters? That's going to be 24. So notice that I am going down 1 here. Now let's think about digits, okay? Once again, we can include 0, so we have 10 digits total to choose from. But let's say I already used 0 and I can't use that number again. Well, I only have 9 options. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, but then what about if I choose 0, 1? Now I only have 8 options because I can only do 2, 3, 4, 5, 6, 7, 8, and 9. Now in this one, we cannot write it like we did in the first or part A. And the reason being is that these numbers are not the same. So we can't use exponents to represent our problems. So here in your calculator, you're just going to have to do 26 times 25 times 24 times 10 times 9 times 8. And so when we plug that into our calculator here, we are going to get 11,232,000. Okay? That'll be our final answer. Okay, make sure if you have any questions, you contact me, and make sure you work on the homework assignment. See you guys later.